Hello everyone. In this video, we will get to know about blockchain. My name is Kanishk. Let's get started. Blockchain technology is decentralized distributed ledger system that records transactions across many computers in such a way that the registered transactions cannot be altered retroactively. Let's understand it using an example. James wants to send $50 to Bob. He creates a transaction request that includes the details of the transaction, his address, Bob's address, and the amount of money. James' transaction request is broadcasted to a network of nodes that are computers in the blockchain network. Each node has a copy of entire blockchain and listens for new transactions. The node in the network validate James' transactions. They check whether James has sufficient funds, verify transactions' digital signature, and ensures that the transaction follows the network rules. Validated transactions are collected and bundled into a block of miner. For example, proof of work system or validate in proof of stake system. James transactions is grouped with other transactions into a new block. The miners compete to solve a complex mathematical problem associated with the new block. This process requires significant computational power. The first miner to solve the problem gets to add a new block to the blockchain and is rewarded with newly mined cryptocurrency like Bitcoin. The new block includes James transactions is added to the existing blockchain. The block contains a unique identifier called hash, and it also includes the hash of the previous block, ensuring the blocks are cryptographically linked. The newly added block is broadcasted to all the nodes in the network. Each node updates its copy of the blockchain to include the new block. Bob can see he has received $50 from James once the transaction is included in the block and that block is added to the blockchain. The transaction is now confirmed and immutable. Now that we have understood blockchain, let's understand some of its key elements. Distributed ledger technology. All participants in the network have access to the distributed ledger and its immutable records of transactions. This shared ledger ensures the transactions are recorded a single time, thereby eliminating the redundancy and inefficiency commonly associated with traditional business networks. Immutable records. Once a transaction is recorded in the shared ledger, it cannot be altered or tampered by any participant. In the event of an error, a new transaction must be added to correct the mistake, ensuring that both the original and the corrective transactions remain visible and auditable. Smart contracts. Smart contracts are digital agreements stored on a blockchain that automatically executes when predefined terms and conditions are met. These contracts are designed to automate the execution of agreements, ensuring all the parties can be immediately assured by the outcome without the need of intermediaries or delays. Additionally, smart contracts can also automate workflows by triggering subsequent actions when specified conditions are satisfied. Now let's understand what are consensus mechanisms in blockchain. Consensus mechanisms in blockchain are protocols used to achieve agreements on a single data value or a single state of the network among distributed nodes. These mechanisms ensure all the participants in the blockchain network agree on the validity of transactions of the state of the blockchain, thus maintaining the integrity and security of the system. There are many types of consensus mechanisms, but some of the most used mechanisms are proof of work and proof of stake. In proof of work, miners compete to solve a complex mathematical puzzle. The first one to solve the puzzle gets to add the next block to the blockchain and receive reward, usually in the form of cryptocurrency. It is secure because altering any part of blockchain requires redoing the work for all subsequent blocks, which requires an enormous amount of computational power. Famous blockchain that works on this mechanism is Bitcoin. POS. Proof of stake validators are chosen to create new blocks and confirm transactions based on the number of coins they hold and willing to stake as collateral. The more coins staked, the higher the chance of being chosen to validate transactions. Validators are incentivized to act honestly because they can lose their staked coins if they validate fraudulent transactions. Some famous blockchains that work on this mechanism are Ethereum, Cardano, and Polkadot. Now, let's move on to real-life use cases of blockchain. Supply chain management, provenance tracking. Companies can track the journey of the product from the origin to customer using blockchain, ensuring transparency and authenticity. For example, IBM Food Trust help track food products to ensure safety and quality. Anti-counterfeiting. Blockchain helps verify the authenticity of products. Luxury brands like LVMH use blockchain to combat counterfeiting. Healthcare. Medical records. Blockchain can surely store and share patient records, ensuring data integrity and privacy. Projects like MedRec aim to create the decentralized database for medical records. Drug traceability ensures the authenticity of drugs and prevent counterfeiting medicines. For example, Cronisled uses blockchain to track pharmaceuticals from manufacturer to pharmacies. Voting system. Secure voting. Blockchain can provide a transparent and secure voting system, reducing fraud and increasing voter confidence. Votaz and Horizon State are examples of blockchain-based voting platforms used in various elections. Identity verification. Digital identity. Blockchain offers a secure way to manage digital identities, reducing identity theft and fraud. Projects like Uport and Sovereign focus on creating decentralized identity systems. KYC. Financial institutions use blockchain to streamline KYC processes, sharing verified customer information securely across institutions. Now let's see what is Ethereum Blockchain. The Ethereum Blockchain is a decentralized, open source blockchain platform that enables developers to build and deploy smart contracts and decentralized applications that are dApps. Ethereum takes the foundational principles of blockchain and extends them with the additional functionality specifically tailored for creating and running decentralized applications and smart contracts. Let's see how Ethereum blockchain builds and differentiates itself from general blockchain technology. Smart contracts. Unlike the original blockchain like Bitcoin, while primarily records financial transactions, Ethereum supports smart contracts. These are self-executing contracts where the terms are directly written into code. They automatically enforce and execute the terms of an agreement without the need of intermediaries. Ethereum Virtual Machine. Ethereum introduced the EVM, a Turing-complete virtual machine that allows anyone to run any program regardless of the programming language on the Ethereum network. This makes Ethereum much more versatile than simpler blockchains. Decentralized applications. Developers can build dApps on Ethereum blockchain. These applications run on a decentralized network rather than a centralized server, enhancing security, transparency, and resilience against censorship. Native cryptocurrency, Ether. Ethereum has its own cryptocurrency called Ether, which is used to pay transaction fees, computational services, and incentives for miners for validating the POS system. Consensus mechanism. While traditional blockchain like Bitcoin uses proof of work for consensus, Ethereum has transitioned from proof of work to proof of stake (POS) with Ethereum 2.0 upgrade aiming to improve stability, security, and energy efficiency. Now let's summarize what we have learned so far. Blockchain is a decentralized distributed ledger technology that ensures secure, immutable recording of transactions across networks. Key feature includes distributed ledger technology, immutable records, and smart contracts, which automate agreements when predefined conditions are met. Consensus mechanisms like proof of work and proof of stake are essential for maintaining network integrity. Blockchain has diverse real-life applications including supply chain management, healthcare, voting system, and identity verification. Ethereum, an advanced blockchain platform, supports smart contracts, decentralized applications commonly known as dApps, and uses the native cryptocurrency Ether known as ETH, enhancing functionality and scalability with its proof-of-stake system. Thanks for watching this video. Do hit the like button and subscribe to the channel.